multiply the following rational expressions. So for the first one, we got 2x squared plus 4x over 8x squared minus 40x times 6x cubed minus 30x squared over 3x squared plus 6x. So the first thing I want to do before I combine these is I want to factor anything out. Factor as much as I can out, rather, from each of the terms. So let's look at the first. We got 2x squared plus 4x. Well, you can write 2x squared as 2 times x, right? And then you could write the 4x as 2 times x. I just basically boiled everything down into its prime factorization. And so notice that there's a 2x in the first term and a 2x in the second term. So we can factor that out. So in the numerator of the first term, if we factor out a 2x, what are we left with? In the first term, we're left with just an x plus 2. Then for the denominator of the first term, let's do the same thing. So we can writing 8x squared in terms of its prime factors, that's 2 times 2 times 2, x times x. And then 40 is 8 times 5, which is 2 times 2 times 2 times 5, right? So 2 times 2 times 2 times 5 times x. And this was a little bit unnecessary, but just so that you guys see, there's an 8x on both the terms. So if we factor out an 8x, what we're left with in the first term is an x, then minus 5. So now let's do the numerator of the second term. So 6x cubed is 3 times 2 times x times x times x minus 30, which is 6 times 5, so 3 times 2 times 5 times x times x. And for these two, there's a 6 and there are 2 x's. And that's all that they have in common. So if we factor out a 6x squared, what are we left with? In the first term, we're just left with x minus 5. And then finally, the denominator of the second term, 3x squared we can write as 3 times x, and then 6x we can write as 3 times 2 times x, and there is a 3x in common on both terms. So we can factor that out, and what's left is an x plus 2. So now we're ready to combine them, and the rule I want to use to combine them is the general rule for combining rational expressions, which states that if you have a rational expression multiplied by another rational expression, the result's going to be the product of the numerators over the product of the denominators. So let's just combine these. So we get 2x, x plus 2, times 6x squared, times x minus 5. And then in the denominator we get 8x times x minus 5 times 3x times x plus 2. Now these are all associated by product, right? We're multiplying everything in the numerator together and everything in the denominator together. So we can cancel out anything that we find in both the numerator and the denominator. So for x minus 5, there's 1 in the numerator and the denominator, which we can factor out and cancel. And there's also an x plus 2. Now there's more reducing to do, but let's first write what we have left. So we have 2x times 6x squared over 8x times 3x. And at any point you could have combined these values, the 2x and the 6x squared, but generally what happens is that you end up having to factor them out to cancel anyway. So I like combining everything at the very end. It's always the least amount of work. So now notice that for the 2 and the 8, you can factor out a 2 from these terms and reduce by 2. So reducing by 2 For 2 you get 1, and for 8 you get 4, right? Because 8 divided by 2 is 4. The x's just cancel out here. Then for 6 and 3, you can reduce by 3. So reducing 6 by 3 you get 2, and reducing 3 by 3 you get 1. And then finally, you can reduce the x squared and the x. So since x squared is just x times x, you can reduce by x. So in the numerator you're going to get x, and then in the denominator you're going to get 1. So now let's write what's left over. So in the numerator we got a 1, a 2, and an x. So that's just 2x. And then in the denominator we got a 4, a 1, and a 1, which is just 4. And this reduces to x over 2. And since there's nothing more to do to simplify, then this is the final result.